So hello everyone. Welcome to today's webinar on vacuum cooling in the baking industry. My name is Esther. I am your contact at Heuch Cooling Solutions for vacuum cooling, and I will be your host for this session today. It is very exciting to have you all here for what is our first webinar in 2025. We are really looking forward to sharing our insights and having an engaging discussion with you today. Before we dive in, a quick reminder, if you have any questions throughout today's session, please pop your questions in the Q&A section and we will address those towards the end. If you feel like we will see actually if we can address some of them throughout the meeting, but because we have an hour, we are going to try to stick to that so we don't take a lot of your time. So most likely they will be at the end. Today's session is packed with valuable information and insights on how the most advanced cooling technology, vacuum cooling, can help your business. We will also be exploring how it has been transforming the baking industry and driving better results for bakeries worldwide. Now let me introduce our panel of experts who are joining us today. We have Hans Juursema. He's the founder at Weber Group. There he is. And global leader in vacuum cooling technology. We have Giel Vermeulen. He's a fifth-generation baker, helping bakeries worldwide optimize their cooling processes as a master baker, advisor, and trainer working for Weber Cooling. Today, some of you will know Nick already. We have Nick Hanley. He's the ANZ Australia, New Zealand, and Asia advisor and consultant. For Weber Vacuum Cooling, he's working with myself very closely at Heuch Cooling Solutions to assess, help, and implement the most optimal vacuum cooling solution for and systems for its business here in Australia. So a quick reminder of what we will be covering today. We will be talking about Weber, how we are also working together with or the relationship between Heuch Cooling Solutions and Weber, the basics of vacuum cooling. We will also do a deeper dive into vacuum cooler with Giel. We will talk about real-world applications of vacuum cooling, and at the end, we will have, as we mentioned before, a Q&A session. We are thrilled again to have you all here today. We are confident that by the end of this session, you will have a much better understanding of how this technology can really take your bakery to the next level. We will also have a special offer at the end of this meeting, so please stick around because we will only provide this offer to people attending the webinar today. It will not be open to anyone else. So yeah, without further ado, I am going to let Hans take over from here. Thanks, Hans.
Can Nick do the first part? Nick, you take the first sheet.
Yeah, sure. So Esther's mentioned the agenda there. So obviously Hans will be introducing the Weber Group, talking about the relationship between Weber and Heuch Technologies. I'll be running through a bit of the understanding of vacuum cooling technologies and its applications here in Australia. Giel will be walking us through some of the benefits of that vacuum cooling and efficiency in productivity and gains. And then I'll come back for some case studies and the Q&A session. So I'll jump into this for Hans.
Yes, then I will give this a start. And what you see on top here is already one sheet back, please. Oh, no, leave it at this one. It's good. You saw the logo, the moving logo earlier, that Weber now is a group of companies. In the past, we were Weber Cooling, and with Weber Cooling, we were supplying vacuum solutions for all kinds of applications. And the applications were mainly in the fresh field, freshly harvested products, like salads, like mushrooms, but also like flowers, like turf and compost. That's where we started with in 2011, finding quick cooling solutions for those applications. From there, we quickly moved also into the food industry, where we see that vacuum can offer a perfect solution to very quickly and homogeneously cool down all the products in the kitchen. And as one of the special applications in the kitchen, we got a request in 2016, the first request, on if we also could cool down bread. And that was our entry into the market of vacuum baking, a market where we really stepped into in 2017, and where we saw that baking or vacuum for baking is a completely different application than for the other, let's say, fresh and food applications. Nick will dive into that a little bit more, and Giel will go into depth. But with baking, it's the only application of vacuum cooling where you really go into the process of the baking. It's the only application of vacuum cooling where you get an enormous amount of advantages on quality, productivity, and shelf life of your product. But it's also an application where you do not just add a cooling solution to your production, you really add a part of your production, or you really include a part of your production into the cooling. So recently we separated the baking from the cooling and made it a second standpoint and a special market segment. And we have a third market segment, which is not so interesting for you, but also since 4 years' time, we're working into the drying field using vacuum as a solution to cool and dry products, fruits, vegetables, and a lot of other products. In the end, Weber is a global supplier. We are doing vacuum. That's our core business. And we try to make applications for cooling and drying, and the cooling for general and for baking applications. That's our core focus. With that, we are not just a supplier of bakery equipment making vacuum coolers. No, we are a vacuum cooling supplier making solutions for bakeries. That gives us the advantage that we have in vacuum technology, we have the economies of scale. Nowadays, we believe that we are the largest supplier of vacuum cooling systems in the world, where we supply well over 100 units on a yearly basis and have an installed base in the market of 700 or 800 units at the moment. We know vacuum, it's the core of our technology. We still are a very small company. We only have around 15 to 20 persons working in our company and around 30 in the production operation. And with that small team, we can cover everything that we're doing. And based on our experience and based on all the machines that we've developed in the past, we believe we have a very intelligent design where we use modular technology and next generation solutions, which we developed partially in the fresh market, in the food market, also in the freeze drying market. And everything that we learn, we also implement into the bakery. And in the bakery, like I said, it's a special application. And there you see on the top of the screen 3 names, Harry, Samuel, and Giel. They will introduce themselves later. But in the baking, as it's such a different application and needs such a special support, we focused very much on getting all the knowledge that we need there to support our bakers. Next sheet, please, Nick. If we look at Weber as a group and the Weber vacuum group now, we want to excel in vacuum. And like I said, we want to do it for all the 3 different applications. And you see here baking as a first one. We have baking, cooling, and drying. Baking for us is one of the most important applications for vacuum, as it brings such huge advantages for our customers. And what we still see is that vacuum for baking is widely unknown within the industry. If I go out and speak to the bakers, 90% of the bakers, or less than 10% of the bakers worldwide, really understand the potential impact which vacuum can have on their application. Less than 2% of the bakers worldwide have a vacuum cooler installed. Perhaps 20 more percent have heard of it, but don't know the details and don't know. And the rest of the 70% of the bakers still is totally unaware of the technology. What our vision is, we believe in the advantages of vacuum for bakery. We believe that within 5 or 10 years time, the majority of the bakers will have a vacuum cooler included in their bakeries, like they added a slicing machine 40 or 50 years ago. And our aim is to make vacuum cooling the new standard in baking by offering very price competitive solutions to the highest standards and the highest reliability, added with all the knowledge that we can bring by Giel, Samuel, and Harry. And with that, Nick, I want to give over to you.
Thank you, Hans. Yeah, so as Hans just mentioned, you'll often hear us or Heuch or a lot of the industry refer to vacuum cooling as a game changer for bakeries. That's not something we take lightly. It is something that we're very serious about. We do see it being a real industry change across bakeries across the world. The bakeries that do install it, the stories that we hear from their space, they never regret it. All it does is give efficiencies into those bakeries. So it's my job a little bit, especially in Australia and New Zealand, to discuss with those bakeries the technology, what it's actually doing, how does atmospheric pressure apply to a baked good. So that's what I'll be going through here. So essentially, vacuum cooling is mostly about boiling water, or all about boiling water, as this references here. So at normal air pressure, like we are here now, sitting in your office or your home office, wherever that might be, you're sitting at about 1,013 millibars of air pressure. And that means that water boils at about 100 degrees centigrade. And essentially, the way you can look at that is a pot of water, as it's cold, has all its molecules held together. As soon as you add energy in terms of heat into that water, that sort of separates and agitates the molecules and releases it as water vapor. And that's essentially what boiling is. The higher you go up in the air, the less air pressure there is. So the less atmospheric pressure you have, the easier it is for those agitated molecules to release into the atmosphere or vaporize, as it were. So you can see here at the top of Mount Everest, you might have heard this be referenced at trade shows or by me in the past, if I've spoken to you before. Water boils at about 70 degrees centigrade at the top of Mount Everest. And that's because there's just less air pressure at the top of that mountain. And as you go higher and higher up, there's less air pressure, so it's easier for the water molecules to escape. And that's essentially the technology that we're capturing with vacuum cooling. We're taking the lack of atmospheric pressure and applying it to baked goods. That has a very specific scientific impact on the product. And we've spent literally years meticulously studying that impact and how we can bring it as a benefit to bakeries across the world. So you can see a couple other references there. You know, weather balloons also have a lower air pressure, so the water boils are less. And on the surface of Mars, water boils at about 6 degrees centigrade, 6 or 7 degrees centigrade. So here's just a reference sheet for that boiling point versus pressure. We often refer to this millibar air pressure in our recipes and how we put that together for each one of our systems. We are aware of the different levels of millibar pressure and the impact that has on bread and bread products. So we'll often use this as a reference sheet to know how to guide it with each specific recipe that we create. And you can just see a little bit more here about the saturation of vapor air pressures and things like that. Just going to mute that. This is just another visual representation of what we're talking about with that boiling point of water. You can see here the air pressure within this chamber here on the left is very, very low, just reaching at 10 millibars of air pressure now. So compared to 1,000 millibars of air pressure, obviously that's about 1%. So water boiling here is boiling at about 12 degrees centigrade, which is sort of hard to wrap your head around about the impact that has, but that's literally happening. And we often demonstrate this at trade shows. We can see how water is boiling at very low air pressure. Some might talk about how that affects the moisture within the bread product. I think Giel will dive into that a little bit more later on, but that's essentially what we're working with. We know how to modify recipes to make sure the impact that it has on the moisture content within the bread is very, very minimal. This is just another video that we can see about the whole process in a little bit more of a visual detail. So I'll just let this run.
how it works.
Oops.
In bakeries, the final step of the baking process, about 35%, involves transferring baked goods from the oven to a vacuum cooler. When the vacuum cooling cycle begins, the chamber is sealed. The pressure inside the chamber is lowered, which in turn reduces the boiling point of water. As the pressure drops, the moisture in the baked goods starts to boil and turns into water vapor, which then evaporates. This evaporation process needs heat, which is taken from the baked goods, causing them to cool down. The vacuum then removes the water vapor through a condenser. Once the cycle is finished, the baked goods are completely baked and cooled. The machine then returns to normal air pressure. The unit is then ready for the next load. This process is, on average, a total of 5 minutes.
So that's a realistic time frame as well. 5 minutes is probably a little bit generous on that part, actually. Most of our recipes will be between maybe 3 and 4 minutes, depending on the type of product, of course. More specific types of products, things like gluten-free bread or meat pies, things like that, do have a bit more of a different profile for the recipe and might take a little bit longer, but still, you know, it's not excessive in terms of time frame. So this is just another way of explaining how, essentially another way we like to refer of vacuum cooling in terms of bakery is cold baking. When you put the bread into the vacuum cooler, it still continues to draw moisture out at lower air pressure and lower temperature. And that continues to boil water or moisture within the product. And that's essentially what we call cold baking. Normally you apply heat and energy to your bread in the oven, and that's baking with heat in the oven. But as soon as we transfer that to the vacuum cooler in that last 35% approximately stage of the baking process, that's where we apply that cold baking technique. So just to run over the advantages of how that vacuum cooling process will impact bread and your bakery. So it's going to improve the quality of your bread. The less time that your bread spends in that microbial phase, that hot phase between, I forget what it is exactly, but I believe it's about 80 degrees to about 40 degrees, the more chance it has for bacteria to grow and for the quality of the bread to be affected. And that's going to impact shelf life, of course, in the long term. The more microbial growth, the more bacterial growth you have in your bread, the longer it's going to last on your shelf. It's going to increase the productivity. You can imagine reducing every baking cycle that you might have in your bakery by 35% is going to have a pretty massive impact on your productivity. And then, of course, the reduction in cooling time is non-comparable to anything else that's in the industry. You're talking upwards of 90 to 95% decrease in cooling time. So that just adds massive impact to productivity in bakeries. And that's why we often refer to it as the game changer. So I think I'm going to hand over to Giel now, who's going to take over and go into a bit more detail about vacuum cooling in a deep dive. So Giel, take it away, buddy.
Yeah, thank you, Nick. You'll be controlling the slides as well, right?
Yeah.
I think just to give you a little knock when you can change that. So yeah, I will introduce myself for a little bit, quite fast, because we are coming back on this part a little bit later with the rest of my colleagues. But I'm Giel. I'm working now for almost 2.5 years here for Weber, and I'm a 5th generation baker. My father has a bakery. His 2 brothers have a bakery, and his nephew had a bakery, but he quit it. So the bakery industry is quite well known within our family. And yeah, I'm really happy to be a part of the Weber Vacuum Group. I've been doing some bakery competitions for the last years. We've done quite well. And since we have learned more about the vacuum technology, I was sold. So I would like to make you as enthusiastic about vacuum cooling as I am at the moment. Nick, if you could show the first slide. and we can dive right in. So, as Nick explained, there is some baking reduction during or some moisture loss during the baking. I will talk a little bit later on when there's the better slide, but here, as you can see, here's a small example how a vacuum cooling would impact the actual process on speed. Because if you can refer here, if you have the normal baking time for 40 minutes, a regular cooling of, let's say, 2 hours, and further processing, you will see here the impact for the efficiency you can make in the actual bakery, because especially the baking time is being reduced, and in this case it's even 30% if I'm not mistaken. So and the cooling time is drastically less. So if you can show the next slide, Nick, then you will see it in a better, yeah, exactly. So if you have the 4 bakes a day, you'll have a 75% more output. And here it makes it really visual with the time frame in the bottom line. If you start at 3 a.m., how the not cooling down of your bread really impacts your product, of your efficiency in the bakery. And so even if you would have some problems with finding staff, or if I'm not sure, Nick, if it's in Australia as well, they have night shift wages.
They do, yes.
In the bakery, yeah.
They do.
Yeah, so here in the Netherlands we have the same as well, and then we see a lot of more bakeries trying to make the switch from starting more early in the night to switching the day up front with starting in the afternoon, so they can avoid the night shift wages. And with the vacuum cooling, they can preserve the quality, so they don't have any loss of quality. So they will start earlier, so it's more relaxed, and they have more time and less stress during their production time. If you can take the next slide, Nick. Yeah, so I'm talking a little bit about quality here. With vacuum cooling, we positively influence the quality of bread. It really depends on what the actual preferences of the customer is, how we can set the vacuum cooler. So we can play, I wouldn't say it's limitless, but we have the sky's the limit. Maybe there's a better way to say it. So we can play really depending on what the customer actually wants. So we talk about the better crumb structure, better crust, freshness, and optimized shape and volume. We have different vacuum settings for depending what you really want. If you really want to have the most volume, if you really want to have the most freshness, the best crust, or the better shelf life overall, we can play and we can really define and fine tune with the customer on how to set the machine. I talked a little bit about the moisture loss. So I want to dive a little bit more here in this. We are losing water during the cooling. And the reason why we lose water is because we lower the boiling point. So we are evaporating water. To prevent this loss, or to compensate for this water loss, we are reducing the baking time. If I can divide the baking steps in 3 steps. In the first step, you have your oven jump. So you have the volume your product gets on the water vapor. It grows on water vapor. The second step, it's the coloring. So it's the coloring stage of your bread. The last stage is your product had the oven jump. It has the color, but it's only stabilizing the product. A really good example of this, it's a panettone. A panettone, you are hanging upside down on a pin to let it cool down, because if you put it the regular way, it's gonna collapse. The reason is because this is actually on the edge of baked. If you would have your bread and you would hang it upside down on a pin, then you can bake it less time, but it's not really efficient. So with vacuum cooling, we are forcing the starches to set rapidly, so we can stabilize the product. It's set And also a really nice example of this is if you have a warm cake, if you bake a cake and you would throw the warm cake on the floor, the cake will break. If you have a cool down cake and you throw it on the floor, it's still in one piece. And the reason for this, the starches have set and stabilized and they're all at the place they need to be. So this is what we do with vacuum cooling, rapidly setting or forcing the starches to set so we have a better stabilization. So depending on what you're looking for and what you want to achieve with the vacuum cooling, we can have the same amount of baking or water loss, depending how you call it, you're currently having, or less. If you want to have more water in your actual product, we can just stabilize your product, reduce the baking time, but keep more water in there. We have another example here in the Netherlands. We have one customer that decreased in their breath improvers because they said we don't need a long freshness. I know we're talking a bit more about this in depth later on. So if you want to have the next slide, Nick. Yeah, we talked already a little bit about the productivity before. You have seen the slides and where you can see where we actually make an impact. Here you have
talk a little bit about the less cooling space on that one, what we mean by that, Giel, if that's okay.
Yeah, no, of course, it's good that you ask. I will go down by them all. So first we have the baking reduction. We talked about this before. The drastically reduced cooling time, because we are cooling down really quite fast. So we save a lot of time on this. The reduction in energy consumption. If you bake less time in your oven, you need less gas to actually use the oven. And you're more productive with the same oven. So you can bake more within the same time with the same type of equipment. And that's where the increased productivity comes from. If you can make more product with your same equipment, then you can increase your productivity as well. The last cooling space, the question of Nick. So normally, if you're waiting for your products to cool down, they are there up on the racks. And for most of the bakeries that I've been to, and it's for the bakery of my father, it's exactly the same. Space is always an issue. So we have a lot of racks being there in the bakery, being there in the cooling area, just waiting to be packed. So if you can pack down faster and you can pack your products, you have less cooling space required because those racks can be used again and they can go back into production. So the faster you can pack, the less cooling space you actually need because it takes less time to have the racks there. The reduced amount of raw materials. I know we are talking about this a bit later on, so I will save it for now. The reduction in labor cost. We talked already a little bit about the night wages. Or is there a better word to say it, Nick? Or
no,
night shift wages.
Yeah, night shifts, night loading. Yeah.
Night loading. So we have the example of our customer here in the Netherlands that switched from starting in the night to the day before in the afternoon until the evening to actually save on the labor cost. And small footprint. Yeah, Esther, tell me.
Yeah, look, I think, we find that a lot of the people that we talk have quite a few questions when it comes down to all of these technical aspects. I would just like to remind all of the attendees that if you have any questions for all of these technical aspects of vacuum cooling, this is your time to please pop your questions in the Q&A section. And either now or later on, either Giel or someone else from Weber will be able to respond to any queries you have. Thanks.
No worries, thank you. And the smaller footprint. We are talking about this later on. You'll see a better calculation of the actual energy use. But because we only need to make a vacuum and we have a chiller to cool down the water, we take less energy than the uses of the gas with the bake reduction time. So we have the reduction in energy consumption, but also it comes down at the end at the smaller footprint for the company. We have the next slide, please. the shelf life. So we have less chance for contamination, longer shelf life overall, extended crispiness of the day, and continued freshness over the week. The contamination. So what microbacteria likes the best, it's heat and humidity. So a warm baked good, it's a nest for the actual microbacteria. They like this really well. So because we are cooling down so fast, we give the microbacteriums less time to actually multiply. So this has less chance for contamination. If you can pack your products within 10-15 minutes after being out of the oven, it has less actually chance to be contaminated with all the goods or all the bacteria being in the packing area, being in the bakery, people walking by. So overall, you have less contamination on the product by cooling it down so fast. So we have less actual microbacteria growing on the product and less exposure to other microbacteriums being in the area. The longer shelf life overall, because I explained in the previous slide about the water content we can control in the product. So if you would like to have more water in the end product, so you have a better shelf life overall, we can play with the settings, of course. The extended crispiness over the day, we are cooling down from the center until the outside. Normally, if you bake in the oven, you bake from the outside to the inside. So in the crumb, there's more water and heat. This moisture goes through the crust back to the outside. So your crust will be getting softer during the day because this regeneration of water is happening. We are cooling down from the inside to the outside. So we take the heat and the water from the crumb, from the center. So this moisture doesn't go back through the crust during the day, if this is what you'll be looking for. You can have the next slide, Andy. So we've been talking about an overview of some products just to show the variety that we can cool and what the benefits are in vacuum cooling. So this will maybe a couple minutes. I will just let them be here. So we have the sandwich bread. I think it's the most mainly product we have the vacuum cooler for. As you can see in the picture as well, we have the better volume, less caving, no keyholes, and a shorter bake as well. Yes, the hamburger buns, here you see as well, we have a better shape. Again, the shorter baking. The hamburger buns, it's a quite ready standard product, so we can cool this in 4 minutes and be way quicker to pack as well. The muffins, this is a nice one. Here we have the maximum volume, a little less shorter baked, because non-gluten developed products, so they can have gluten or not gluten. They are more fragile for the baking reduction, but I will go a little bit more in depth on this, where we can get more benefits from muffins and cakes later on in the slide. Sponge cakes, it's the same story for as the muffin. We stabilize the product as well, so we keep a higher volume overall. You can have the next one, Nick. The croissant or viennoiserie. This is actually, in my opinion, where we have the nicest impact on the products. Here you can see the layering. Here you can see the better structure and the volume as well. This is actually a wonderful product to vacuum. Gluten-free. I think everyone here that has seen vacuum cooling being used in gluten-free can share the same opinion. If you have a gluten-free bakery, vacuum cooling is almost a must. It's such a game changer. We can shorten the bake, we can maximize the volume, no cavings, and have the better structure. This is gluten-free. It's a bit more, I wouldn't say a difficult product, but it has some, people who make gluten-free know it has some difficulties during the process, but that's why me and my colleagues are here to help you through the whole process to get the best results you're looking for. You can have the next one, Nick. The French baguette. Here again, it's almost the same. The shorter bake, the longer crispiness during the day. This is really what my heart makes a jump. If you have the vacuum cooler, if you see the crispiness we bring on the products, it's phenomenal. I would actually ask you to if you could only feel it, you have the same excitement as I am. But unfortunately, this is a digital one. But maybe in the future we can have a 6D webinar. You can have the next slide then. Yeah, a rye bread. Of course, with rye bread, this is the same as the gluten-free. It has not developed or not with gluten at all. So this has quite standard, really long bake. So a lot of water because the rye and the brand they're observing a lot of water. So we can shorten the bake here really in minutes. We have one customer in Germany. We actually took off 25 minutes of their baking time because they were baking so long, and it saves them a lot of time in their process. You can have the next one. Yeah, the bread with inclusions. Here you can see on the picture as well. This is actually a Dutch product. This is raisin bread. We have here almost 100% of filling on the flour weight, so it's a quite heavy product. We have here the maximum volume, better structure, and again, the no keyholes and caving. So you can see here, this product, it stands like a house, if I can say it like that. So it just looks lovely. Can I have the next one?
Raisin bread's very popular here too, at least in my house, that's for sure.
Okay, good. So here we can talk a little bit more about the reduced energy costs. So this is for a rack of 60 kilos we have made here. So the vacuum energy needed, it's 1.4 kilowatts. We don't have the prices of power and of gas, of course, it's different in every area. This is the standard one we have made. So baking one rack, it's 3.5 cubic meters of gas. If we can save off the 30%, we save 1 cubic of gas per rack. There's no additional cooling energy required. The vacuum pump we have of 4 kilowatts runs for 6 minutes, 0.4 kilowatts, and the chiller runs for 5 minutes, it's 1 kilowatt. So here we make the calculation. So for this one, of course, we have a chiller that is chilling the water. Once the water is cooled down, it's not actually running, but we needed to put some minutes on this to make the calculation, because once the water in the chiller has been cooled, then it shuts off, and it only continues when cooling is needed. Oh, there's a question. Let me see. So there's a question. I'm going to read it out. Do we want to answer the question now, or we want to keep it for the question?
Yeah, go ahead. Giel, answer the question, please, if you like.
Okay, of course. Is what you are saying is that within 5 to 10 minutes, the product is no longer releasing any moisture at all. So condensation in packaging does not occur. It's correct. Yes, it's correct, depending on what the end temperature will be of your product. So we can cool down quite deep. We can cool down to packing temperature, but we also need to keep in mind what are we doing with the product afterwards, and can you pack as fast? We had one example. We had a customer in South Africa, and they wanted to pack directly. And then my question was, if you have racks coming every 8 minutes, can you pack a full rack within 8 minutes? And they weren't able to pack those within 8 minutes. So then we give the advice to, instead of going 30 or below, we say go a little bit higher, let's say 40 degrees, and then have the 10-15 minutes of buffer, because what we see in practice is most of the companies, they cannot pack immediately because they always have a 10-15 minutes of putting the rack in a different area, going here, talking with a colleague. So to answer the question, condensation does not happen during the packaging, of course, depending on the actual packing area. The condensation is that the temperature of the product, it's or the temperature between the product and the environment is too much apart from each other. So if your packing area is 25-30 degrees and your product is 33, even 35, I would say we can manage that to pack, then we have no condensation in the packaging. If your packing area is 5 degrees, then of course we still have condensation. But if you, in normal conditions, we don't have any condensation. If you're packing directly from 35 or lower Celsius after cooling. Can you put the next slide there for me, Nick? Now, potential saving on raw materials. This is mainly for cake products, so sponge cakes, muffins. What do we have more? Regular loaf cakes, pound cakes. We talked about here we have more better volume, but only 10 to 20% of saved baking time. The reason for this is not gluten developed products are more fragile and less stable to resist the changement in pressure. But we have seen in practice with our customers, they have a higher volume. So if you see the product here on the left has a higher volume than the product on the right, because we stabilize the product and we force the starches to set. If you want to use less batter to have the same height, so let's say we can reduce the 10 or 15% of batter weight in the shape to have the same volume, you use less batter, so you can save on raw materials. But also, if your product is, instead of 250 grams of cake, and you take 15% off, so that is 37 point something, 37 and a half if I'm calculating quickly, then you also need less baking time because you have less weight, so it has an extra saving in the baking time. So this is not a direct saving baking time, but if you want to have the same volume with less weight, we can also save a little bit extra time during the baking because we have less weight than we originally had. I'm not sure if in Australia there is any law for dry matter, Nick. In the Netherlands, we have a law that for a whole loaf or a half loaf, we need to have this and this percentage of dry matter. I'm not sure if it's the same thing in Australia, but
I'm not sure. I don't have any insight into that, unfortunately. Maybe someone can post that in the chat if they're aware of that.
Okay, so it doesn't apply for all the countries, especially not here in the Netherlands. We are quite forced by law, but we had one customer in Kazakhstan where they weren't happy with the increased volume of their muffins because it was too big for the packaging. So we decided to take off 15% of the batter weight, and they made quite some multiple millions of muffins a year. So they saved quite some raw materials on this. You can have the next slide there. The enhanced quality. So you mainly see with, for example, weaker flours, or you have quite some difficulty getting the actual volume you want. If we can stabilize the product so it doesn't collapse after baking, we can, of course, together with my colleagues, we can look into your recipes on, hey, how can we save some money by changing a portion or completely to a different, more cost-effective flour. If you want to look into this. And the same is for the bread improvers as well. If you want to look for a better shelf life, and we can have a discussion with me and my colleagues, and hey, how can we make the most benefits from vacuum cooling? But this would be my advice to go later on. Once you have your product implemented in your bakery, and after a couple of months, when you have the regular production going through, we can go look more in depth on, hey, how can we save more time or money during all at the end. You have another slide, Nick? I think we're almost nearing the end. Yeah. And then I give the word back to you. If I'm looking at the clock, I think I talked too much, so my apologies for this.
No, you're good, buddy. Thank you. Okay, so I'll just quickly run into a couple of case studies here, two in Australia that we have that I want to talk about for two very distinct reasons. The first one here is the Red Hill Baker. The number one reason that Ray, his name is, if you haven't been to the Red Hill Baker down in Balnarring, I highly suggest it. It's one of my favourite bakeries in Australia. But he was all about the quality that he saw from the output of the vacuum cooler. He loves his crunchy sourdough breads, and he loves his crunchy baguettes, and he loves his pies. So they're a couple of things that we really focused on with him. He's now had his installed for approximately 5 years, I want to say. And these are just a few of the sort of benefits that he could see from that. He increased his output for his wholesale business. So he now supplies a lot of the baguettes and sourdoughs to a lot of the local cafes and local areas. Some of the supermarkets around as well. And he's expanded that since installing the vacuum cooler. He's also moved his staff away from as much night shift as he possibly could. And I believe it was within the first year, he'd already seen a revenue increase of about 20% just for a few of those benefits since installing the vacuum cooler. And that was a combination of those labor inputs and the energy reduction that he definitely saw. This is another another bakery here in Victoria. A gluten-free bakery. So they wanted to expand their production, but they didn't have this availability for more space. So vacuum cooling is something that they'd looked at for a long time. And once we got their system installed, they're extremely happy. They could immediately see the space-saving effect that it had on their bakery. And another sort of side effect that they noticed was the change in ambient temperature that it actually brought into their bakery floor. Because of course they were taking their racks of baked product and leaving it in the same room, letting all that heat and energy escape into that same room, just blowing cold air of it, which is just of course moving that hot air around the room, and using the vacuum cooling system, they're expelling all that heat and energy out through the condensation system, and that immediately changes the ambient temperature of their facility. So that was just one byproduct that they happened to notice. Massive impact on their productivity, as you can see from these charts here. These are some of the reductions that Giel worked on with the gluten-free bakery to reduce a lot of their baking time and increase their productivity. So that's just two examples within Australia. Of course, Hans can probably speak to how many hundreds have been installed across the world, especially all throughout Europe and Asia. Very, very popular over there and increasing in popularity here in Oceania. So I think I'm going to throw over to Hans again now, or is this Giel?
I will introduce my colleagues, and then, or I will announce them, and then I will let them introduce themselves. So we have, of course, our team with world-class people that we really want to help, and this is what makes Weber unique and what makes us different from the rest. We have a team that is here to help you guys on all the fronts. But first, we have Samuel. Could you introduce yourself?
Yeah, hello, hi to everybody from Spain. My name is Samuel Suarez. I've been in the baking industry for 22 years now. I got my baking degree in London in the South Bank University. It's the oldest school in the UK. And I did my studies there in baking and patisserie. And when I finished my studies, I worked in factories in London doing new product development. I worked for Harrods, the well-known brand worldwide luxury store in the bakery there for 8 years. And then I travel around Australia, New Zealand, working in bakeries as well. So I got a very wide perspective of the bakery. I can do artisan baking. I can do industrial baking. Then I returned to Spain and I worked for a chain of 200 supermarkets doing the new product development products, raw frozen, par bake, proven frozen products. So I have a very wide information about how the vacuum can help you. The vacuum for me is quite new as well because I started with Weber 2 weeks ago. So I'm still getting to grips with all the information. But I had a trip to Holland like a month ago, and I got to see how the technology works. And it's amazing because, as I said, a few years ago, the bakers will start to use retarding chillers into the bakeries. And slowly, as Hans said, we start to getting bread slicers, we start to get proofers, retarding proofers. So I think the vacuum is the next big thing to come into the bakeries, and for me, it's a discovery, it's a new discovery, and I'm very excited to share it in the Spanish market and with all the Latin American countries. And well, I will have here the Spanish market, so all my knowledge and support will come to the artisans and big industry. I think it can be applied to everything. So very happy to be here, guys. Very happy to be with the Weber family, and very excited, very excited.
Thank you for your introduction, Samuel. It was I couldn't have done it any better.
Thank you, thank you.
I already introduced myself already a little bit. Maybe a nice fun fact to know: the competition where Samuel became the world champion. I did the same competition and I lost from Samuel, so I became in fourth place. So
yeah, I forgot to say about the titles. I mean, after so many years working in the industry, I felt like I had something to prove. So I entered the Spanish Best Baker competition, which I won first time, first try. And this opened the door for me to the Spanish national team, which we have, like you do in Holland. We have a national bakery team. We all from different parts of the Spanish Peninsula, and we get together and we go to competitions. We went to Rimini to the World Cup, and as he says, I compete against him, and luckily Spain won. It's the first time Spain won the gold in any competition, bakery worldwide. So it's a small world because look at us now. We're working together.
exactly.
I'm 43. You're 24, I think, or 25. So you still have a lot of years to try. But for me, it was that chance. It was only that chance to win.
Exactly. This year we're gonna have a rematch in 2021. Became our team did the European Championship and we became second in France. And this year in October we're gonna do a rematch. So we want to be the European champion, and then the World Championship we're gonna do again after quite some years. It was a bit of a but from now I want to introduce my other colleague as well, Harry. If you can introduce your history within the bakery.
I've been born in the bakery of my parents, and 65 years ago. And after working in a lot of bakeries in the Netherlands, I start with as a salesman for bread improvers, and I'm an expert in that kind of job in the Netherlands, and I do that for 25 years. So I'm very happy to have these new colleagues. I started in the beginning of this year, and I know the vacuum cooling very well. So yeah, I like to do this job.
Thank you, Harry. So as you can see, we have our team ready. So we are. So yeah, good. Thank you, Nick.
Giel?
Yeah, tell me.
Thank you so much, and thanks everyone for those short introductions. I am a little bit conscious about the time. We are
Yeah,
6
sorry.
p.m. So I would like to ask all participants to please ask any questions you may have now. As you can see, you have everyone. Everyone, you have a master bakers, the team, Weber team. So yeah, please, if you have any questions, now it would be the time before we wrap up. Like I said before, we have a special offer. So if you could just stay with us for just a few more minutes, I will then share that with you after the questions. Thank you.
Do we want to wait for the questions, or we need to continue with the slide as well?
Yeah, if we can just wait for a minute. Also, for all the participants, we also generally like to know what are the challenges that you are facing. So if you would like to maybe also pop in that Q&A chat, any challenges that you face where you believe vacuum cooling can help, maybe one of our experts can also share some insights just on that. Thanks.
Esther, can we also see the questions as well, or?
Yeah, okay, so I guess there may not be questions, or maybe they're a little bit shy, the rest of
Well, that
participants.
means we've done our job properly. That's the main thing.
We will keep going, and but yeah, look, we only have a few minutes, so if we can just take a minute or two to wrap this up, and then I will share. Well, actually, we have a question here. So the question is, how well does vacuum cooling work for meat pies or with meat pies? So please, whoever feels more, yeah, can help a bit.
I can speak to that a little bit. So the Red Hill Bakery is a great example of that. So it does work. As with gluten-free, it is a little bit more intricate to handle because meat pies, depending on your gravy content, it can have a rupturing effect where the moisture content boils out of the crown of the pie. But using the right control technology, and as I said, probably a little bit further than what you'd normally have with your 4 or 5 cooling time, we can achieve that. Red Hill Baker use it for their pies. They do about 40 kilos worth of pies per cycle, which is obviously quite small, but in comparison to a lot of other systems. But we know that scales up with the type of chambers that we use. In fact, the Red Hill Baker recently won the Pie of the Year competition for I think it's their beef burgundy pie. And speaking to Ray, he accounts 100% victory for that towards the vacuum cooler, and that's it might sound like hyperbole, but that's coming from him. So we're quite proud of that. So it does work with meat pies.
Yeah,
yes.
we also see it at other customers, and what is important there, Nick, like you said, the splashing that you can have. You can modify that partially by the recipe, but that's also where Harry comes in. With just a small modification in ingredients, a small modification in recipe, you can prevent the splashing of the water.
Yes.
So it really helps there. And what we see from experience also is that the taste of the pie is getting a more rich taste.
Yeah. We've also recently had a food company purchase a system. This is also going to answer the second question that I see popped up. We did some demonstrations recently in Australia here for spaghetti bolognese, so just the bolognese sauce. We did tubs of, I think it was about 13 kilos of bolognese sauce. And we used a special lid system to stop any sort of ruptures or boil outs from that occurring. And we managed to achieve very good success with that also. So they're now installing a system.
Yeah.
Yeah.
And in relation with the demo, the question about the demo unit, we do have a vacuum cooler demo unit here in Melbourne at Heuch Cooling Solutions. So we do run some tests from there. What we find, however, with bakeries is that they need to pretty much have it at their premises, because you want to get the bread, all the different types of breads or products that you produce basically being tested on site. So this week, tomorrow, actually we have the demo unit going to a client here in Melbourne, a prospect. They are going to have it over 3 days, and we will be there supporting them, testing a variety of products. So I will send information about this after this webinar in relation to how you can request a demo and what is involved. Yeah, for that.
Any more questions?
Okay, so yeah, if Giel, if you would like to just cover this slide, then just yes.
Yeah, of course. We have some testing bakeries around the world. We have one in the Netherlands and one in Japan. Yeah, of course. Like Esther explained, we are quite flexible in rental and purchase solutions. The demo unit in Australia, if you're not already, or if you want to see the product with or the results on your product in your bakery, then the demo unit is perfect to actually experience firsthand on what vacuum cooling can offer for you.
Great. Nick, would you mind please oh, okay, so yeah, this is the different range yeah, of systems that we offer. If you could just so Nick, I don't know if you would like to share anything else here, but it basically depends on the amount, the volume that every bakery needs yeah, to use the vacuum cooler for. Then once we go through the assessment, we then provide yeah, we suggest which one we believe will help them achieve their objectives.
Yeah, I think you said it pretty succinctly. 99% of the time, we're going to be custom making these vacuum coolers because people have different rack sizes, different needs, different attributes to their baked goods. So we always tailor-made our solutions.
Thanks. Nick, are you able to please share the slide that I sent with you before?
I think I can do that. I'm not sure if that's showing up on your screen.
Okay, so we are going to wrap this up now. I would really like to thank everyone from Weber who has joined and helped present this webinar today. I hope it was really insightful for all the attendees. As you can see from Heuch, I work really closely with Nick. Without him, we really couldn't offer this product. So please get in touch with us if we can help you with a quote, a demo, a feasibility study, or to look into how to hire a vacuum cooler.